Okay, so let's summarize what you learned about quadratic functions and their graphs yesterday. First of all, some terminology. Quadratic, remember, is anytime you have a polynomial expression, function, or equation of degree 2, meaning the highest power of x is 2. Our standard form for a quadratic function is f of x equals ax squared plus bx plus c, where a of x squared is the quadratic term. And that term right here is really, really important because it tells us the behavior of the function. The bx is the linear term and c is the constant term. We'll talk about that a little bit more in a minute. The name of the graph of a quadratic function is a parabola. Just like a linear function, its graph is a line. For a quadratic function, the graph is a parabola. All right, so quadratic functions have two directions of opening. They either open up, or we say they open upward, like this first parabola you see graphed here, or they open downward. So in order for the parabola to open upward, the leading coefficient on the quadratic term, which is that ax squared term, has to be positive. So if you have a positive leading coefficient, the parabola opens up. A good way to think about it is if it's positive, it's smiling. So it's like a smile right here. Where if the leading coefficient is negative, so the a value is less than 0, and you have a negative leading coefficient, the parabola will open downward. So kind of think about it, if you're in a negative mood, you probably would be frowning. So it's a frown. So unlike exponential functions or linear functions, quadratic functions actually increase and decrease. And that point of where their behavior changes is called the vertex. So the vertex is the highest or lowest point on the parabola, and it's in the center of the parabola. It's the turning point of the parabola. So if your parabola opens upward, your vertex is at the bottom, so it's a minimum value. Where if your parabola opens downward, the vertex is the highest point on there, so it has a maximum value. Parabolas also have an axis of symmetry. So the axis of symmetry is just this imaginary line that goes directly through the vertex, and the points around it are symmetric on each side. So it's like if you took your parabola and you folded it along this imaginary vertical line, and you folded your paper, it would come together perfectly on each side. So it cuts the parabola into two equal parts. This line of symmetry for quadratic functions is always vertical, and there's a formula to figure out this axis of symmetry, and it is x equals the opposite of b over 2a. And we get that a and b from our standard form, from that ax squared plus bx plus c. All right, other key features that go with all graphs are always our x-intercepts and our y-intercept. So recall, anytime we have a y-intercept, the value of x is 0 because we are on our y-axis. So if I take this standard form, y equals ax squared plus bx plus c, and I was to substitute 0 in for x because I'm trying to find my y-intercept, what would ultimately happen is when I multiply whatever a is by 0 and whatever b is by 0, those terms would just go away and I would get c. So that's why anytime we have our quadratic equation in that standard form, ax squared plus bx plus c, the constant term is always the y-intercept. Okay, to get our x-intercepts are a little bit different because remember, anytime we have an x-intercept, y is equal to 0. So in that case, you're going to take your equation, and I'm just going to use the basic formula, ax squared plus bx plus c, and you're going to set it equal to 0. Well, once you set it equal to 0, you're going to go back to what we learned in Unit 5, and you're going to solve it by factoring. And we have learned all the different ways to factor, whether we are factoring a binomial or a trinomial or with 4 terms. So you'll just factor, and when you're done, you get the x-intercepts. Now, x-intercepts are special because they have some other terms that mean x-intercepts. So as weird as this is, you may see a question where it says, what are the intercepts, or find the x-intercept? Or it might call them the roots. Or it might say, what are the zeros of the function? Or the solutions to the equation? As weird as that is, all four of these words mean the exact same thing. If it says to find the x-intercepts, or to find the roots, or to find the zeros, or the solutions, they all mean find the x-intercepts, or to solve and find the solutions of the equations. All right, so let's put all this together and do some problems. Okay, so for our very first problem, we are given y equals x squared minus 4x minus 5. The first thing I'm going to do is figure out how is this parabola going to open. So since the leading coefficient of the x squared term right here, it's already in descending order, it's in perfect form, and I might even just write that up here for y'all real quick. Y equals ax squared plus bx plus c. So since that leading coefficient, that a value is 1, it is positive. What that tells us is our parabola is going to open upward. And I'm just going to kind of jot that over to the side. It opens up. Something else we know without doing any work is the y-intercept. We automatically, because this is in that standard form, know that the y-intercept is going to be -5. All right, so if you were graphing this with some graph paper, you could go ahead and come over here to your graph paper and put a point on the y-axis at -5. All right, the next step is we got to find the center of this graph. And to find the center of this graph, we got to find the vertex. But the only way to do that is to find our axis of symmetry. So that's going to be our next step. We're going to do the axis of symmetry. And to do that, we have to use our formula. X equals the opposite of b over 2a. So that is going to give us x equals. Our b value right here is -4. And if you want, you can always write these over to the side. A was 1, b is -4. So if I need the opposite of b, and b is -4, then I'm going to have +4, divided by 2 times a, and in this case, a is 1. So that's really saying x equals 4 divided by 2, which is x equals 2. And that's really important, because what that tells me is over here on this graph paper, the middle of this graph is going to be at x is equal to 2. So now I've got to figure out, well, where on this imaginary line is the vertex? How high or low is it? So since I know that the vertex lies on this imaginary line, now all I have to do is substitute 2 back into this equation to figure out what the y value is. And of course, you can use Desmos or your calculator to do that. But if you didn't have it, all you're doing is saying 2 squared minus 4 times 2 minus 5. And if you didn't have any technology, that would just be 4 minus 8 minus 5. So we would get that that is -9. And so we would put that together. And I'm just going to write this real quick. Our axis of symmetry is x equals 2. And then we put that together with our vertex. So the x coordinate of our vertex is 2. And we just found the y coordinate to be -9. This is the most important point on this graph. So I'm going to go ahead and put that over there. All right, so then actually you already have another point. You may not realize it, but you do. Because we can see that the y-intercept is 2 units to the left of the axis of symmetry, that means there has to be a point 2 units to the right of the axis of symmetry. Now, of course, we could create a table. We could put this into Desmos and create a table and get some other points very quickly. Or we could find the x-intercepts. So remember, if we want to find the x-intercepts, what we need to do is let y be 0, because anytime you have an x-intercept, recall that y is 0. So all we do is we take this equation that we have, and we replace the y with 0. So it's 0 equals x squared minus 4x minus 5. And now we're back to what we were doing last week, and we can solve this by factoring. It's already set equal to 0. The leading coefficient is 1. It's a trinomial. So we can do the shortcut method and create our 2 sets of parentheses. So we'll pop an x in the front of each one, since that leading coefficient is 1. We ask ourselves what 2 numbers multiply to -5, but add to -4. And those numbers would be +1 and -5. So we pop those in the back, +1 minus 5. The next step is we set each factor equal to 0. And then we solve. So we would subtract 1 here and we get x is equal to -1. And we would add 5 here and we get x is equal to +5. So those are 2 more points on here. One's at -1, one's at +5. And if you look at it, it makes sense. you're kind of checking that symmetry again. Notice that both of these x-intercepts are exactly 3 units away from the axis of symmetry. When you're using the Delta Math program, it refers to these points as the roots. It'll say, you know, make sure to use the roots, the vertex, and 2 other points to graph your parabola. And then we can graph our parabola. There are actually points all in between these points. We just got some critical points to help us graph it. Some properties of this parabola is that the domain is all real numbers. There's no restriction on your domain in this case. It goes to the left forever and it goes to the right forever. However, the range is not all real numbers because it does have a lowest point, and that's that vertex. And remember, that vertex is the point to -9. So if we think about it, the lowest point on this graph, the minimum value of this graph, would be -9. It's always the y value. So the vertex is the minimum point, but the minimum value is actually -9 because that's the lowest y value graphed on there. So to state the range, we would say it's all real numbers greater than or equal to -9. And a lot of times we just say y is greater than or equal to -9. Or you can write that in words, all real numbers greater than or equal to -9. And that is how you graph a parabola with all its key features by hand. Now, of course, you can use Desmos also to graph these. You can go into Desmos, you can type your equation in. You can then click on your little bolt up here. I like to duplicate first and then change it into a table. And the table will give you a few points. If you would like a few more points, you can always hit enter, because one of the things I want to make sure that I see is the vertex, and I want points around that vertex. That vertex point is really, really important. The cool part about making a table is it'll start to highlight those points on here. You can always go and click on them. You can see the vertex is the point to -9. If you wanted to make sure you had your axis of symmetry right, you could add that in here, x equals 2, and it would graph that axis of symmetry. Remember, you can always change if you click on this and hold, sorry, I don't want that slider on there. All right, so if you click right here and hold down, you could change it to be dashed if you wanted, so that it wouldn't, you know, or more dotted, just because it's really not part of the graph. It's imaginary. It just helps us to do the graph. You can always check your roots. Remember, the roots are the x-intercepts. So you have a root here at -1. You also have a root here at 5. You can also check your y-intercept. Of course, we can also do this in the graphing calculator, but since everyone does not have a graphing calculator at home, we know that when y'all start Math 2 next year, that we are going to have to work hard on teaching you all the calculator steps, especially to help you prepare for the ACT, SAT, and they're a little bit more involved, but we will get there. So feel free to use Desmos to help you also. Okay, so let's say that you have a problem like this in your practice today. Graph the equation y equals -x squared plus 6x minus 8. You must plot 5 points, including the roots and the vertex. Use the graph to determine the vertex of the parabola. Okay, so let's check this out. All right, well, we know the parabola would open downward because a is negative in this case. We also know that the y-intercept is going to be at -8. So that's helpful because that could be one of your points that you can use to graph your parabola when you're putting it on there. And of course, you can use graph paper at home and sketch it, or you can go straight to the program and put it in. So I've gone ahead knowing that -8 is my y-intercept and just clicked that point on there. So that's one of the 5 points I need. Okay, so then we need to find our axis of symmetry. So we have x equals the opposite of b over 2a. So we substitute our numbers in. So that's x equals the opposite of 6. So that would be -6 divided by 2 times -1. So that's really -6 divided by -2, which would ultimately be +3. So I know that when I graph this, there's going to be that imaginary line at x equals 3. And I know that my vertex is going to lie on that. So I'm going to go ahead and jot that down. My axis of symmetry is at x equals 3, but I also now know half of my vertex because if x is 3, what is the y value? And again, you can do this by substituting 3 back into the function and using your calculator. You can do it by using Desmos. There's lots of different ways to figure that out. Okay, so ultimately we get the vertex is at 3, 1. So again, we can go ahead and put that right here as one of our points. And we know that the vertex is one of the points we must have on our graph. So now let's find the roots. Okay, so guys, to find the roots, those are the x-intercepts. So we set the equation equal to 0. One of the things I do not like about this is the x squared is negative. But now that I've set this equation equal to 0, I can actually divide this entire equation or multiply this entire equation by -1 and change all the signs. And as long as what I do to one side I do to the other, I'm allowed to do that. That's like the golden rule of solving equations. So what it's going to do is it's 0 will stay 0, and then everything else will change signs. So it's now positive x squared, negative 6x plus 8. Why did I do that? Because it makes it a lot easier to factor. I now have a positive leading coefficient of 1, so I can shortcut. What two numbers multiply to positive 8 and add to negative 6? That would be -2 and -4, and you can FOIL or box to check that. We then set each factor equal to 0, x minus 2 equals 0, x minus 4 equals 0, and we solve to get that the roots are x equals 2 and x equals 4. Two different x-intercepts in this case. So I'm going to come over here and put those on my graph. Wow, there they are. And they're both 1 unit away from the axis of symmetry. And then since I had this y-intercept way down here that's 3 units to the left of the axis of symmetry, I should have a point also 3 units to the right of the axis of symmetry. So I'm going to go back and I'm going to add these points onto our graph here. And I'm going to make sure I've got it in the right spot. And bam, there it graphs my parabola for me. And then I want to make sure I answer the other part of this question. It says, using the graph, determine the vertex of the parabola. Well, since the vertex is a point, I need to pick that I'm typing in 1 point, and then I would type in what the vertex is. So I would type in 3, 1. Oops, sorry, 3, and then over here, 1. And then submit that answer. Yes, I wanted it to be 3, 1. And then it goes through and shows us we did it correctly and where the vertex is. Don't forget that there's also videos that you can do for watch help videos. Sometimes these questions will change. In this case, it wanted you to determine the vertex. It may say, what is the axis of symmetry? So let me just do a new problem real quick. If it said, determine the equation of the axis of symmetry, when you got down to your answer, hold on, I'm just going to make up something real quick that doesn't even work for this problem. Just to... Okay, so what I would do is I would come right here and I would put in one equation. And I would type x equals 2. Because the axis of symmetry is always a vertical line, so you have to type x equals. Or if the question was saying, what are the roots? That's when I would want to pick that I want to type in 2 numbers. And then I would type in those roots. And I wouldn't have it on this one, but just if I did. Okay, I hope that helps. And we will be doing some applications tomorrow.